Okay, here we have Chapter 10, which deals with the conic sections. So conic sections just refer in general to the curves that are generated if you slice a plane through two cones that meet point to point. We'll talk about how that comes up in each individual section. So the first section here, 10.1, deals with Introduction to Analytical Geometry. So this is doing things like midpoint, distance, and determining whether shapes are the given shape or not. So here we have the objectives. Find the distance and the midpoint between 2 points, and then prove geometric relationships among points and lines using analytical methods, so by analyzing the information that you have. So here's your distance formula. The distance between 2 points given x1, y1 and x2, y2 is given by d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So there's your formula. So first example here, find the distance between the points. I'm at negative 3, 7 and 2, negative 5. So the distance formula looks like this. So filling in our values. So that's the square root of the quantity. So x2 is 2 minus x1 is negative 3. So that's going to be 2 plus 3 squared plus the quantity. So y2 is negative 5 minus 7 squared. So that's 5 squared plus negative 12 squared. 25 plus 144. 69. So they are 13 units apart. So here's another kind of question. Determine whether the quadrilateral ABCD with vertices at 3, 2, 2, negative 4, negative 2, negative 3, and negative 1, 3 as a parallelogram. So A is at 1, 2, 3, 1, 2. B is at 1, 2, 1, 2, 3, 4. C is at negative 2, negative 3, and D is at negative 1, positive 3. So there's your shape. So for this to be a parallelogram, opposite sides have to be parallel. So AD would have to be parallel to BC, and CD would have to be parallel to AB. So to do that, we need to find the slope of the line for AD and the slope for BC, find the slope for CD and the slope for AB, because they have to be the same. So AD is 3, 2. So the slope of AD is going to be 3 minus 2 over, so y2 minus y1 over 3 plus 1. So that's 1/4. So and then we need BC, so the slope of BC, so that's going to be negative 3 plus 4, negative 3 plus that, negative 2 minus 2 is, where am I doing? Oh, well, sorry. I'm off by a sign somewhere. AD 3 minus 2, oh, those are backwards. Negative 1 minus 3, so that's negative 4. So this is also negative 1/4. So those are parallel. So I need to do the same thing with the slope for CD. So that's going to be 3 plus 3, 3 minus that, negative 1 plus 2, so that's 6 over 1 over 6. And M of AB is going to be negative 4 minus 2 over 2 minus 3. So y2 minus y1, x2 minus x1. So that's negative 6 over negative 1, so that's 6. So opposite sides parallel. So yes, it's a parallelogram. Here's our equation for midpoint. If the coordinates P1 and P2 are x1, y1, and x2, y2, then the midpoint of P1, P2 has the coordinates x1 plus x2 all over 2, y1, that is a plus sign, plus y2 over 2. So it's the average values of the x's and the average values of the y's. All right. So here's our third example, midpoint that has negative 2, 4, and 6, negative 5. So it's going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2, so that's 4 over 2, comma, negative 1 over 2, so that is the point 2, comma, negative 1/2, and that would be the midpoint. And that's the end of the section.